There are three main ideas about teleportation. One where your body is moved, one where only your information is moved, and another one that we'll talk about later. The most important thing is, though, that you should definitely stay away from all of them. At least for now, I think. First, the most classic vision of teleportation is the one where every atom in your body is transferred through a transfer channel. You step into a machine designed to take you from point A to point B, let's say from New York to Tokyo. Using an absurd amount of energy, it dematerializes your body in New York and transfers it atom by atom through electromagnetic waves, like light or radio waves, to get reconstructed in Tokyo. Upon arrival, another absurd amount of energy is used to reconstruct your body, placing each atom exactly where it should be. Now, we don't know the exact amount of energy required to teleport a human being, but we do know it would be astronomically high. Just to dismantle and reassemble 7 octillion atoms, which is the approximate number of atoms in our bodies. That's a 7 followed by 27 zeros. But let's assume humanity has already developed the technology to store all this information and generate all this energy. Even so, this teleportation has some major issues. There could be errors in molecular reconstruction, like misaligned proteins or corrupted DNA. If this teleportation process made mistakes in materialization, it could make a slightly distorted version of you or even leave out parts. Since this is a theoretical field, we can't say with 100% certainty what the consequences would be. Another issue is you could be rematerialized with limbs in different positions from the original. But the biggest and most sinister issue of all is that dematerialization would necessarily imply your death. In other words, the version of you that arrives in Tokyo is just a perfect copy of you, but not truly you. Or at least not the version of you that was dematerialized in point A. Other weird things could also happen, like a power failure or a bug causing your matter to remain stored for days or even years until the issue is resolved and you're finally rematerialized. Luckily, teleportation has more forms, but this one also has an eerie side. Quantum teleportation. In this second form of teleportation, there is no transfer of matter, only information. To clarify, in physics, information basically refers to the arrangement of particles. Let's use some analogies to make it clear. Imagine you need to bake a cake. The physical ingredients of the cake are different from the recipe and the preparation method. You could receive the recipe through a communication channel, for example on a piece of paper. In this case, the information about the cake is transmitted to you via paper and ink. If you received the recipe by email, it was transmitted to you through electromagnetic waves, photons, and electrons via fiber optic or copper cables. Even though information is linked to physical objects, they are not the same thing. Some physicists theorize that information may have a physical nature, but there is no consensus yet. Similarly, imagine you go online and search for sand castles for sale. Instead of physically receiving the sand, you receive an extremely detailed manual in your email, explaining exactly where each grain of sand should get placed. Then you get some sand, put it in your ultra-advanced 3D printing machine, and use the manual to build the sandcastle you bought online. Quantum teleportation is kinda like that. Instead of sending your matter atom by atom, what is sent is the information about absolutely every part of your body, especially at the atomic level, like a cake recipe or the sandcastle manual. The problem is that, at the atomic level, a particle's properties are described by what's called its quantum state, which is basically its rotation, energy, and position. These factors serve as a complete description of a particle or quantum system. However, it's impossible to measure a quantum state without directly interfering with it. This means we can't know its exact position and velocity at the same time. The more precisely we measure one variable, the more uncertain the other becomes. This is known as Heisenberg's uncertainty principle. In other words, this isn't just a technological limitation. It is a fundamental limitation of nature itself. The way to make this teleportation possible is through quantum entanglement. Entanglement happens when two distinct particles have their quantum states correlated, regardless of their distance, whether it's 1 kilometer or light years apart. In quantum entanglement, the state of one particle is the opposite of the other it's connected to. For example, if particle A's quantum state is measured as spin up, then particle B's state must necessarily be spin down. However, due to the no communication theorem, which states that quantum information cannot be transmitted during measurement, the stored information must still be transmitted via classical communication channels, like fiber optics, light, or internet cables. Now, an important point about quantum teleportation. it does not create a perfect copy of the original particles. There's something called the no-cloning theorem. This principle in quantum mechanics states that it's impossible to make an exact replica of an unknown quantum state. Unlike classical information which can be copied without problems, quantum states are unique and cannot be duplicated without altering their properties. In other words, in quantum teleportation, the information about the state of particles is transferred and recreated elsewhere, but the original particles are destroyed in the process. As mentioned earlier, this form of teleportation faces the same problem as classical teleportation. The you that enters point A in New York is not the same you that exits at point B in Tokyo. Essentially, your first version no longer exists. It was destroyed. And even though the version that emerges from teleportation is identical, it's still just a version of yourself, with your memories and emotions, but still not you, which is terrifying. Of course, there are many debates in this field trying to answer this question about what would actually happen and what it means to be you. But we can roughly divide this problem into two main perspectives. First, assuming we exist in a 100% material universe, meaning we're just a cluster of atoms that together form life and consciousness. This implies that since teleportation only creates copies of you, the you that enters one side no longer exists, and only another version of what you were remains. Since dematerialization or quantum destruction at point A means the end of that cluster of atoms, it essentially means death. The second possibility is that we live in a universe with layers of immateriality. That is, we're not just a cluster of atoms, but a combination of body and soul, with the soul being an immaterial element that exists, beyond matter and was given to us by a higher consciousness. In this case, destroying the body at point A would once again mean death. However, even if your body appears at point B, it would just be an empty shell without life inhabiting it anymore. Regardless of any scenario, in both cases, these known models of teleporting imply your death. And that's why you should stay very, very far away from any form of teleportation. But what if there was a method that did not require dismantling or destroying you? You might already be guessing I'm going to talk about wormholes, but unfortunately, they're just as dangerous as the others. The problem is, first, we don't even know if they exist. We only speculate because mathematically, they are possible. Second, they're like bridges in space-time, not magic doors instantly connecting two points. Some movement is still required. Third, they are very, very unstable. We would need to master space-time manipulation to an extreme degree, and even then, it would be difficult to keep them stable, especially making them large enough for humans to travel through. In the worst-case scenario, you could be crushed by space itself or thrown across the universe if one collapses while you're inside. Theoretically speaking, of course, since their feasibility hasn't been proven yet. But this video is just a warning. If someone tries to convince you to step into a teleporter, think twice before accepting, because things might happen. Or maybe I'm just being too alarmist. The truth is, technologies that may seem simple today would have been considered magic years ago. Perhaps in the future, a safer and more practical form of teleporting will be created, and this video will become completely pointless.